Good day, guys. Welcome to Calcumind. We'll also be looking at another method of solving ordinary differential equation, which is separation variable techniques, whereby we'll separate the y parameters onto one side and the x parameters onto one side, and later on integrating it. So let's look at this first question, whereby the y over the x is equal to y squared multiplied by x raised to power 3. So we're going to be taking this y squared over to one side and the x squared over to one side, as I said earlier. So we are going to see this operator as a fraction, and we are going to be cross multiplying. So dy will be multiplying y squared x cubed multiplied by dx. So from this equation, we can see that y squared is intruding into this equation, whereby it's supposed to be only x squared. Only x. We can see x and also see x. So now we are going to be dividing all through by y squared. So let's say dy divided by y squared, and this other equation divided by y squared dx. So now this will come out as 1 over y squared dy is equal to s cubed dx. So we can see this, and now we have noticed that this is positioned like this and x squared multiplied by dx. So what we are going to do is simply integrate the equation. So we are going to integrate So this is going to be integral of 1 over y squared dy is equal to integral of x cubed dx. So now this is integral. From our laws of indices, we can note that 1 over y is equal to y raised to power minus 1. So this is the idea we are going to be using here. 1 over y squared is going to be equal to y squared minus 2 dy, which is then be equal to integral of x cubed dx. So now we are going to be using integration, whereby using the laws of integration, we are going to add 1 to this side and bring down n plus 1, which is minus 2 plus 1. So that's what we are going to be doing. So this will be y minus 2 plus 1 divided by minus 2 plus 1, which will then be equal to, doing the same thing, 3 plus 1 divided by 3 plus 1. So this is the integral of, it's going to be 3 plus 1 divided by 3 plus 1 plus c. We should not forget our integrating constant, very important. So this will be y minus 1 from this point divided by minus 1 is equal to x raised to power 4 plus c. So y minus 1, from this reference, we can note that it's 1 over y. And this minus, we're going to take it up. So it's going to be minus 1 over y. This y, we are bringing it down because of the minus attached to it. And there is an invisible 1 here, but it's not so necessary. So it's going to be equal to x4 plus c. So now we are tasked to make y the subject of the formula, not just minus 1 over y. It's y that is our main focus. So we'll make y the subject of the formula, whereby we are going to take the LCM of these two parameters. It's going to be looking something like this, divided by 4. 4 divided by 4 is 1. 1 times x raised to power 4 is x raised to power 4 plus, this is going to be a 1. 4 divided by 1 is 4 plus c. This is 4c. And note that from this point, y is equal to minus 4 divided by x4 plus 4c. So this is our final answer from the whole equation. So now we are going to be solving equation 2, whereby t cos t is equal to 2x plus e raised to power 3x dy over dx. Okay, this is a second question we are going to be attempting, whereby we are presented with, rather than y, we are presented with t. So whereby we'll separate the x variables on one side and the t variables on one side. So this is what we are going to do. So we are going to be dividing the whole equation t cos t. We are going to be dividing all through by 2x plus e raised to the power 3x. So this 2x plus e raised to the power 3x is equal to dx over dt. So now we are going to be seeing this function as an operator and be cross multiplying this and cross multiplying this. So this is dx multiplying this 2x plus e raised to the power 3x multiplied by t cos t dt. So whereby we'll be integrating this function. This will be integral of 2x plus e3x dx. The same thing we did with this problem earlier, and doing the same thing to this to be t cos t dt. Okay, we'll be using integration by part to solve this part of the equation, whereby integral of t cos t. So now, using the integration by part, we are going to summon the formula, which is basically u dv is equal to uv minus v du, integral of v du, whereby we can state that u is equals to t and dv is equal to cos t. So we are going to be differentiating this one to get du. So du over dt is equal to 1, and dv, we are going to be integrating dv to get v. So that is the idea. dv is equal to v. So now v is going to be integral of dv, which is cos t. So if we integrate it, it's going to be giving us v is equal to sine t. So now we are going to be substituting it into the equation, whereby we have gotten our u, which is equal to t. Then v from our solving is equal to v from our solving is sine t minus v again, which is sine t, multiplied by du, which is 1. Am I on track? So we are going to be further expressing this equation, whereby t cos t is equal to t sine t. So if we integrate this, if we integrate sine t, it's going to be giving us what? So it's going to be minus cos t. So now this integration is going to be giving us t sine t plus cos t. So that is the solution for this aspect of this equation. So now we are going to be solving for this other portion, which is 2x plus e raised to the power 3x. So we are going to be differentiating this 2x with respect to the x, and also this point with respect to the x. So we are going to be breaking it down. It's going to be integral of 2x dx plus integral of e 3x dx. So now if we integrate it, we are going to be adding 1 to the 1 and also dividing it by 1 plus 1. So this is going to be 2 integral of x dx plus integral of e 3x dx. So now we took the 2 out of this, and we are going to do as I earlier said, this is 2 integral of, x 1 plus 1 plus e 3x divided by 3. If you have like this kind of exponent, you're basically going to differentiate this point and divide it by what you have differentiated. So we are going to further simplify this. This is 2x squared over 2 plus e3x divided by 3. So this 2 is going to take this 2 out. It's x squared plus e3x divided by 3. So we have gotten one fraction. We are now going to sum it up with this. So it's going to be, since we are further, let's not forget our integrating constants. We're going to add it with this, which is t sine t plus cos t. So that is the final answer for this equation. Make sure to like, share, and subscribe. And hope you join the community in the description below. Thank you.